For these rational functions, you're now asked to find the intercepts, both x and y. So we're going to start out seeing if first we can reduce the fractions down. Remember from previous problems, if you can reduce and cancel out a factor, that's where a whole is. And you don't want to confuse a whole with, for example, an x-intercept. So for right now, let's see, the numerator doesn't factor. Or if you're going to pull out the number 1. And the denominator, we'll go ahead and give that a try. This factors into, we need the x times x to get x squared, multiplies to -6, but adds to -1. So a -3, +2, check and multiply, FOIL it out, make sure that it multiplies back to x squared minus x minus 6. Nothing cancels here, which means we don't have any holes in the problem, which is good. So now we're going to go ahead and find our y-intercept. So I'm going to let x equal 0 and then solve for y. So y equals, I have 0 minus 7 and 0 minus 3 times 0 plus 2, or -7 over -3 times 2. And keep simplifying it. -7 over -6. When you divide two negatives, that results in a positive. So I have one y-intercept at 0, 7, 6. To find the x-intercept, you let y equal 0. So I go back to my function and let y equal 0. And I've got x minus 7 over x minus 3 times x plus 2. With these, I like to set the 0 over 1 and then do a cross multiplication. Clears out the fractions pretty quick. 1 times x minus 7 equals 0 times that denominator. But 0 times anything is just 0. So that wiped out the fraction pretty quick. And now just solve for x, add 7 to both sides. And I get x equals 7. So when y is 0, x is 7. So I'm going to put the 7 in for the x spot and 0 in for the y spot. And those are your two intercepts. Scrolling down here, again, if it looks like something you can factor, you'll want to try to do that first. So I'm going to put down my two sets of parentheses, both top and bottom. And on top, x times x minus 7 plus 1 multiplies to -7. -7 plus 1 adds to -6. On the bottom, 2x times x is 2x squared. I need to multiply to -1. And I kind of take a peek at what I have up here. I know the signs have to be opposite, so I'm going to put in a -1 here and a +1 here on the off chance that maybe these cancel. Now let's take a look. I have -1x, +2x, but that adds up to a +1x, and I needed a negative in there, so it didn't factor right. All that means is I just need to change my sign. So I make this a plus and this a minus, which is going to change my signs here to a +1x and a -2x adds up to a -1x. Now I've got this multiplying right. And again, look to see if anything cancels. Well, this is now an x plus 1. It's not going to cancel with an x minus 1. All right, so there's no canceling, which means I have no holes. So I move forward then to my x-intercept and my y-intercept. So I'm going to take my fraction, x minus 7 times x plus 1 over 2x plus 1, x minus 1, and let y equal 0. For an x-intercept, put 0 over 1, cross multiply. So 1 times the numerator is just going to be what the numerator is, equals, there's my equals, 0 times whatever the denominator is. But again, 0 times anything is just 0. Set each factor equal to 0, solve for x. So this one has 2 x-intercepts. Subtract 1, and I get x equals -1 or x equals 7. So those coordinates are 7, 0, and -1, 0. For the y-intercept, you let x equal 0. So I'm going to be plugging in zeros for my x's here. 0 minus 7, 0 plus 1, 2 times 0, which is just going to be 0 plus 1, and 0 minus 1. So simplifying in the parentheses, -7 times 1, and 1 times -1. So I have a -7 over -1, which is just 7. So my y-intercept is 0, 7. So I have 3 intercepts in that problem. For the last one, once again, you'll want to see if you can factor. Now this one you can take an x out. The denominator is just x minus 1 with nothing to cancel. There's again, no holes. So I go through and start looking for my x-intercept and my y-intercept. So for x-intercept, you let y, or f of x, equal 0. And I can put again 0 over 1, do my cross multiplication. 1 times the numerator is just the numerator, equals 0 times the denominator is 0. Set each factor equal to 0, solve for x. So x is equal to 0 is a factor, and that's an intercept. X minus 6 equals 0. Solve for x, add 6, and I have 2 x-intercepts. One is going to be at 0, 0, and the other one at 6, 0. Go to the y-intercept, and this is where I go back and let x equal 0. So y equals 0 times 0 minus 6 divided by 0 minus 1. 0 times anything is going to be 0 over -1, which is 0. So our y-intercept is also at 0, 0. This one, they give you a picture and want you to find the different characteristics. So vertical asymptotes are ones that go up and down and have the equation x equals, because it crosses the x-axis. So for the first vertical asymptote that I see, it's x equals, and it crosses at -3. This one, vertical asymptote, crosses at 3, so it's going to be x equals 3. That's why we kind of make a point, when we're talking about x-intercepts, we write them as points, not just leave it as x equals 6, because if I wrote it as x equals 6, someone might get confused and think that's the entire vertical line, x equals 6. Vertical asymptotes are lines. Horizontal goes this way, and it crosses the y-axis at -4. So it's y equals -4. The domain goes from left to right. So starting out here at -infinity, I have part of my picture going off in that direction. So the domain starts at -infinity, and then comes right up to your vertical asymptote here at -3. Notice it doesn't touch the vertical asymptote, nor does it cross it, so we're going to use a parenthesis there. Or there's a picture between -3 and +3. Again, with the vertical asymptotes, it's not going to cross those. Your graph isn't. And then starting at 3 and going out to infinity, you still have a picture that's going to squeeze on down here close to +3, x equals +3, all the way out to positive infinity. For x-intercepts, I look along the x-axis and I don't see that my graph touches or crosses, so that has no x-intercepts. Y-intercept, I look on the y-axis and I see that it crosses here at 1. So that would be the point 0, 1.